In the midst of all the hoopla concerning Einstein's theories, two interferometer experiments stood out very uniquely. One was performed in 1913 by the French scientist Georges Sagnac, the other by Albert Michelson, Henry Gale, and Fred Pearson in 1925. Whereas all other interferometer experiments were designed to determine whether the Earth was revolving around the Sun, these two were designed to detect a rotation between the Earth and space. Both the 1913 and 1925 experiments discovered the rotation and did so by detecting the presence of ether, but in proportions that were 20 times greater than that found in the 1887 Michelson-Morley experiment. In the 1913 Sagnac experiment to detect for rotation, two light beams were made to travel in opposite paths. The results showed that one of the beams moved slower. The difference between the two beams became known as the Sagnac effect. Sagnac thus proved absolute motion and falsified relative motion, and relative motion was at the very heart of Einstein's relativity theory. Whether inadvertently or deliberately, we do not know. But Einstein failed to mention Sagnac's experiment in any of his papers, yet it was probably the most important experiment of the 20th century. Sagnac writes,
"In clear conception, it ought to be regarded as a direct manifestation of the luminiferous ether. The observation of the optical effect of such a relative wind of ether would constitute evidence for the ether, just as the observation of the influence of the relative wind of the atmosphere on the speed of sound in a system in motion would, in the absence of a better explanation, constitute evidence of the existence of the atmosphere around the system in movement. It's been very easy for me to find at the outset the evidence for the ether by causing a small optical circuit to rotate. The observed interference effect is clearly the optical whirling effect due to the movement of the system in relation to the ether, and directly manifests the existence of the ether supporting necessarily the light waves of Huygens and of Fresnel.
The importance of Sagnac's experiment would be proven many times in various applications, but none was as important as when the global positioning satellites were put into orbit in the 1970s. In order to compensate for the fact that electromagnetic signals between GPS stations are slower when traveling west to east than east to west, the GPS satellites must be pre-programmed with a Sagnac correction in order to work properly. This is a fact that is generally hidden from the public. Instead of admitting that the GPS computers work off of the Sagnac effect, modern scientists often claim that the GPS is proof of the theory of special relativity, which includes the constant speed of light as its fundamental basis. But the GPS shows that the speed of light is not constant and needs to be corrected in accord with the results from Sagnac's 1913 experiment. The second phase of this particular interferometer research was the Michelson-Gale experiment of 1925. Instead of testing for a revolution of the Earth around the Sun, Michelson now tested for a rotation of the Earth. Unlike the 1887 Michelson-Morley experiment that produced only a fraction of what was expected for an Earth revolving around the Sun, Michelson and Gale acquired results that were almost 100% of a daily rotation. That is, there was enough ether drift against one of the light beams in the 1925 experiment to account for the full daily rotation we experience on Earth.
This was astounding news, but also very puzzling for modern science. How could one experiment in 1887 fail to measure a revolution of the Earth around the Sun through ether, but another similar experiment in 1925 measure a full daily rotation through the same ether? This was especially puzzling, since an Earth revolving around the Sun would be going at least 66 times faster through the ether than an Earth spinning on its axis. One would think that the faster one is traveling through the ether, the easier it would be to detect it.
Michelson, like most in the modern scientific community, was a heliocentrist, but his two experiments did not prove a revolution of the Earth around the Sun, only a daily rotation. Thus, all he would dare claim from his experiments is that he was able to demonstrate a rotation of the Earth, but not a revolution of the Earth around the Sun. But let's look more closely at his conclusion. Did Michelson prove the Earth rotates, or did he merely prove a relative rotation between space and the Earth? In other words, based on the results of his 1925 experiment, Michelson could just as easily have concluded that ether-filled space rotates daily around a fixed Earth as opposed to the Earth rotating against a fixed ether. The answer to this question is decisive, since his 1887 experiment did not measure a movement of the Earth around the Sun, but his 1925 experiment, using the same ether-based apparatus but oriented in a different way, measured a daily rotation. Simple logic requires us to conclude that space, which contains ether, rotates around a fixed Earth. Of course, Michelson, blinded like everyone else by the Copernican principle upon which he based his whole scientific career, was not able to see this logic. Although by detecting the presence of ether, he confirmed that special relativity was wrong, he was trapped by his devotion to Copernicanism and thus could not envision the correct answer to replace special relativity. The 1925 Michelson-Gale experiment is important for another reason. In the heliocentric or acentric system that Einstein defended, the Earth must be rotating on a 23.5-degree axis in the sidereal time of 23 hours, 56 minutes, and 4.1 seconds. And also be revolving around the Sun in 365.25 days. As such, in order to explain A. all the observed movements of the stars and planets, B. the Earth's day-night rhythm, and C. the 4 seasons, heliocentrism cannot have a rotation of the Earth without a revolution of the Earth around the Sun. But the empirical evidence from Michelson's 2 experiments performed in 1887 and 1925, respectively, showed only a rotation, not a revolution. The problem for devoted Copernicans is thus quite obvious. Without the Earth having both a revolution around the Sun and a rotation on its axis, heliocentrism is impossible. Therefore, the natural conclusion should be that Michelson falsified heliocentrism by the empirical evidence from his 2 interferometer experiments.
This leaves us with only one solution that answers both the 1887 Michelson-Morley and 1925 Michelson-Gale experiments. The universe is rotating around a motionless Earth. It is the only solution that answers all the empirical evidence.
There is only one other solution to Michelson's 1887 experiment, but in the end it also fails. It is the ether entrainment theory that was proposed by both Lorentz and Michelson soon after Michelson's 1887 experiment, but long before his 1925 experiment. The theory asserts that the reason Michelson did not measure the Earth moving against the ether at 66,000 miles per hour around the Sun is because the Earth carries the ether with it. If such was the case, both of Michelson's 1887 light beams would experience little or no ether drift. The problem with this solution became quite apparent by 1925, however. If ether entrainment was used to explain the 1887 Michelson-Morley experiment, it would contradict the 1925 Michelson-Gale experiment. Michelson-Gale necessitates that the ether cannot be entrained with the Earth, otherwise the experiment would not have found a 98% daily rotation of ether against the Earth. Instead, it would have found a near zero rotation rate. As it stands, the entrainment theory does not answer all the empirical data and should be discarded.